Welcome back to my channel. Let's try to solve this problem. The longest substring without repeating characters. So what does this problem say? So we need to find the longest substring. Substring means continuous. Longest substring which has unique characters. Let's look at the example. A B C A B C P B. So what is the longest substring that has unique character in this? ABC is the string that we have unique characters. CAB is the unique string that we have unique characters. Again, ABC unique characters. Yeah, these are the unique substring that we can find, and the maximum length of that would be 3. Here also same. Only B is the one that can have maximum substring. So if you come here, we have the unique characters at this place, KEW, or the unique substring that we can find with the maximum length. What is the first solution that comes to our mind? The first solution that comes to our mind is, let's generate all the substrings and let's find the length of the let's generate all the substring. We have to see if the substring has any repeating characters. If it has a repeating characters, we don't need to consider that. If it does not have a repeating character, then we have to check its length. Once we get the length, we just have to store that length somewhere and get the maximum of all the lengths, or just basically we have to get the length of all the substring that has unique characters. So here, what would be the time complexity? The time complexity for this would be we have to generate each substring, that would be n square, and for checking the uniqueness of the character, again, how are we checking uniqueness of the character? Are we again, let's consider the optimum approach where we are using the hash map and where we're using hash set, where we check if the substring has a unique character or not. If we that would be n. The time complexity for that would be O of n. So if we consider the total time complexity of this problem, O of n square for generating the substring and for finding the uniqueness of the characters, O of n internally. For each substring, for each substring generated, we have to find the uniqueness. So that would be O of n cube. So that's very slow algorithm. So how we can try to optimize this solution? So let's try to understand the solution. Okay, here we need to find a way which stores what all characters I have visited previously. How we can do it? We can store it somewhere, or we can save it in a hash set. Hash set I'm using it because we can save it. We get to know if the character is present or not in the constant time. That's why I'm trying to store it in hash map. Okay, let's say how we can solve this problem. Okay, I come to this point. I don't have any. I've not visited this before. So yeah, now I'm putting that in my hash set. The hash set as A. Now I'm going forward. I have not visited B. I'm putting the B in a hash set. Now the C is there. C is also not visited in my previously. I'm checking in the hash set if it is there or not. If it is there, we'll look into it. If I don't have I don't have a C here, so I'm appending that in an hash set. Okay, now I have reached till here. Now let's say I have entered this guy A. How come here? I have seen A before, so which is there in my hash set. So what I need to do? I need to so basically I know that I'm till here. I've reached till here. So what I have to do is, let me just change the color here. We know that I have reached till this point and A is already been visited once. So what I need to do? I need to remove all the elements from the set so that the A that I'm adding it here will be unique again, right? The a that I'm adding here will be unique again. So here so for that I need to save from where I'm starting. So let's consider 2 points. One is start, one is end. Start, I'm removing a. Let's say I'm removing the a. I'm checking if the second, what is the condition? I have to make sure that the a that I'm adding here is unique again, right? So I need to verify if a is there in my hash set. If it is there, remove that a. I'm removing it a. Now what happened? I removed a. Now my start is from here, and my a. Yeah, I'm appending a. Now I check to my hash set again. I don't, because I removed a, right? I don't have a in my hash set now. I'm appending a now here. Now again it's the same loop. I'm coming, my end point is to b now. B here. I've been removing this e. Now what happens? Now b is there in my set. Similar way I will be removing b from my hash set, and I'm checking bb. With the same I removed the b, and I'm moving forward my start point, and I'm verifying it with b. Again I'm adding b in the hash set. The cycle, similar way the cycle continues, and whenever we find a new the repeating character, right, we just have to make sure we just have to calculate the length of the start, and from where I'm starting the substring and from where it is ending. So I just calculate the difference. E minus start plus 1 will be my length of that particular substring at that particular point of time. Okay, so I'm using hash map here, so that I need to make sure I am having this unique characters. That's one point. Okay, let's I have it. What's the time complexity here? So in the worst case I'm traversing e, I'm traversing s. So let's say the length of the string is n. The time complexity of the solution in the worst case would be O of n plus n. So that is O of n would be the time complexity of this solution. Okay, I have implemented this solution. Let's see how it is implemented. Okay. Yeah, I have declared all the things. This is the important point, that this part is important point that I have mentioned. Okay. Yeah, this is the part where I'm checking if I don't have the character that I'm at is not there in my hash table, not there in my hash set. I'm appending that character in my hash table, and I'm finding the length and storing it in my answer, and I'm just moving forward. Okay, here at this point also what I'm doing, this part removes the characters until my end is becoming unique again. Whenever I'm adding the last point, it has to be unique again. Until then it will be removing the characters. So if you see here, yeah, if you see here, it will be removing again. The important point to note here is I'm checking if the second guy contains, because whenever I need to be adding the second element that I'm adding has to be unique. That's why I'm removing this character and adding it. Okay, that's why you see here I'm removing all the elements from the beginning until my second character is becoming unique again. In this way I'm calculating this length, and this is how I have implemented the solution. The two solutions that we saw at this point, one is normal brute force solution, where we get all the substrings first, and for each substring we check the uniqueness of the character, and if the character is unique, we will consider that as one of the solution for us, and we just calculate the length of it and store it in the answer. What the time complexity of is the time complexity of that, and if we consider the finding the uniqueness as optimized algorithm, the time complexity of that would be O of n cube, And the space complexity would be, if we consider, yeah, the space complexity would be, at the worst case it would be O of n, where we'll be storing all the values in an hash set to get the uniqueness of the characters. Okay, now the second solution, the which is optimized solution, which is O of n space complexity that we mentioned earlier, and the space complexity would be still O of n, because we will be storing all the characters in an hash set. And yeah, that's the solution. Thank you.